So when I left you last, I had asked you to do the next two problems on your worksheet, on your slideshow packet, that were very similar to this. They looked like, I think, this guy right here, which looks exactly like the curve on the problem I did for you, but the numbers are different. And I asked you to do this one. So I'm going to just, I set it up. So if you're having trouble setting it up, you can see how I set it up here. I'm not going to talk a lot about how I did this, but I set the 50 and the 4 as my Q and P2 respectively, the 20 and the 5 as my Q and P1, and then I worked it out. Notice 50 minus 20 is a positive 30, but 4 minus 5 is a negative 1, but I ignored the negative. The negative means absolutely nothing to us. We don't care about it. Again, demand curve is always negatively sloped, so one of the two is going to be negative no matter how you set it up. So I worked it out. I got 2 over 0.2, which comes out to about 9. And I knew from the total revenue method that this was an elastic curve. And so if I go back and check with my rules here, which are here, 9 is greater than 1 the last I checked, so this is elastic. So that worked out pretty well there. So if you have any questions at this point, let me know, and I will be more than happy to help you. So if you go and do this one, you know that at each price, this should be inelastic. So you should get a decimal for your answer. I don't know what the decimal is. I haven't worked that problem out in quite a while, but you should get a decimal. So that's a way to check yourself. Now, I'm going to talk, again, in generalities about this formula to try and help you think not so much about the math, but about the concept. So what could we say about the elasticity of this product? What do you think here? Is this more like apples, or is this more like insulin? Look at what happened. When the price went up, what happened to the quantity demanded? It did absolutely nothing. It stayed the same. No matter what the price was, the quantity was right here. Now, is that insulin or is that apples? Well, when the price of apples went up, we said, hey, I'm gonna go buy bananas or oranges, so the quantity is going to change a lot. But here, the quantity is not changing at all. So this is like insulin. And if you want to think about it as far as the formula is concerned, we know that this is inelastic. We can see it's inelastic too, because we talked about how the steepness of the curve can also be an indicator of elasticity, although not necessarily always is that the case. But if we look here, let's try and put some numbers to it. Let's try and quantify this a little bit with our formula. So the quantity, the percent change in quantity, let's deal with that. Can we do that? It looks like the percent change in quantity here is 0%. There is no change. Okay? That should be a big hint to us. The percentage change in price, it could be anything. Because if the top is 0, 0 divided by anything gets you what? 0. So let's say it's a 100% increase. It doesn't matter. It could be a 2% increase. It's still going to equal 0. Now, go back to your list here. Well, that's less than 1, so it's inelastic, but I'm going to add a rule here. If your price elasticity demand is 0, that's something that we call perfectly inelastic. All right? Perfectly inelastic. So insulin is pretty close to being perfectly inelastic. And when you see it, so it looks like this. This is, I'm going to write it out. This is a picture of perfectly inelastic. Now, anything between 0 and 1 is what they call relatively inelastic. And so 0 is a special type of, gets its own special name. All right. Now I'm going to take a second. I'm going to pause here for myself, and I'm going to rework this graph a little bit. Okay. Hang on a second. So now I took the demand curve, and instead of being a vertical line, now it's a horizontal line. What can we say about the elasticity of this problem? Well, hopefully, since you just saw the inelastic one, and I changed it an incredible amount, you may be thinking, well, this has got to be elastic. And when we talked about elastic before, we talked about you get a more mellow demand curve. Well, you can't get any more mellow than this. And you notice this looks like the marginal revenue or the demand curve in perfect competition. Well, that's because that's kind of how the demand curve from perfect competition for those firms, this is exactly how it worked, where the price, what do you notice happening to the change in price here? The price isn't changing at all, but the quantity of demand, the quantity demanded can change an incredible amount. So any deviation away from this particular price, you weren't going to be able to produce if you were that firm. That wasn't going to work out for you. So here you see the percentage change in quantity demanded. Well, actually, let me do this. Percentage change in price. What's going on with the percentage change in price here? We're at a whopping 0% again. And again, it doesn't matter what the percentage change in quantity demanded is, because it can be 1%, it could be 100%. Anything divided by 0 gets you what? An error on your calculator, or it's unknown. So this is what we call perfectly elastic. Okay? So anything that is unknown, or I guess it's kind of like infinite, but an unknown, oh shoot, wrong one. An unknown price elasticity of demand equals perfectly elastic. Alright? And then anything in between, say, anything over 1 but not unknown, or is relatively elastic. Okay? So that is just a little bit to try and help you think more about the concept of this formula than to think about have to worry about the math. But you do have to worry about the math, and so you're going to have a couple problems here in just 1 second. So you know all the rules for the midpoint method. So now you've got a couple things to do. First, the next 2 slides on your packet look like this guy. Be careful here. I am trying to trick you. So be careful. You're going to figure out the price elasticity of demand. You must, in this case, use the midpoint method. You cannot use the total revenue method to figure this out. So your job is to figure this out. Is it elastic, inelastic, unit elastic, perfectly elastic, or perfectly inelastic? It could be one of those 5 there. So your job is to figure that out. And then this problem is the same exact problem that we calculated with the total revenue method, but you're going to calculate it with the midpoint method. All right, that is your job. See if you get the same answer. If you get elastic with one and inelastic with the other, somewhere you made a mistake. Okay? And then the last thing that you're going to do to practice your price elasticity of demand, you have a worksheet. This is page number 2 after the slideshow. You should have done these problems with your total revenue method, but now you're capable of answering this with your midpoint method. And I know there should be a graph here, but I don't have it on my computer like that. So, but there's a graph on yours. So you're going to use the midpoint method. Be very careful down here on this problem, because there are a lot of things that are being asked for. So follow close attention to the price ranges that I'm asking you about. So I asked for 3 price ranges here for you to calculate elastic, inelastic, or unit elastic. All right. And again, you might need another piece of paper to do this. It might not be easy. There isn't enough space here to do that all on the worksheet. Okay. So those are the things that I want you to do right now.